Some generic diagnostic trouble codes also apply to a CVT transmission. These codes typically have a 0 in the second position after the P. These codes can cover solenoids, electrical issues, and some of the sensors that can be found inside a conventional and CVT transmissions. Codes can indicate that a module is not talking or sharing information. For example, any modern transmission needs to know the throttle position. The throttle position sensor is wired to the engine control module. The data from the sensor is processed by the ECM and shared with the transmission control module on some vehicles. This is done using a serial data bus. On most CVT equipped vehicles, this will be a high-speed controller area network bus or CAN bus. Another type of code you might encounter are communication codes. These codes typically start with the letter U. U indicates that a module or entire serial data bus is not working. If the modules are not talking at all, common codes you may see in the ECM and TCM are U0073 for control module bus A off, or U0100 for complete loss of communication between the ECM and PCM on other modules in the vehicle. The corresponding code for the transmission is U0101 and U0121 for the ABS module. Remember, communication codes hardly ever work solo. If there is a U code in one module, there will be another U code in other modules on the serial data bus. In some cases, they can point you to which module that is not talking. In other situations, they can indicate more significant problems like issues with system voltage or grounds, or even a weak battery that may be causing transmission codes. Other codes can indicate electrical issues with solenoids, stepper motors, and actuators inside the valve body. Many codes will tell you if the circuit is high, low, or open. High, low, or open codes often refer to the resistance in the circuit. Okay, time to think like a TCM. If you look at the wiring diagram of a transmission control module on any transmission, you will notice that solenoids and actuators do not have individual fuses. Many of these components use 12 volts with considerable amperage. The driver that completes the circuit are typically located on the motherboard of the transmission control module and don't use a relay. So what would happen if a solenoid was shorted to ground? Well, typically you'd damage the entire TCM, but there are other safeguards to prevent this from happening. Most TCMs or ECMs are looking for voltage drop the second the circuit is turned on. A transmission solenoid will have a known value of resistance. So if the voltage drop is too little or too much, it will not power the circuit and set a code. But every time the TCM is turned on, the system will check the resistance using bias voltage and a signal to see if the problem is resolved. Some CVT transmissions will use a stepper motor that actuates the control pressure to the primary variator. The stepper motor connects to the ratio control arm and the ratio control valve. The other end of the ratio control arm connects to a pulley follower. The ratio control valve changes the transmission ratio by changing the pressure inside the pulley. The transmission controls the module, sends the signal to the stepper motor in a specific pattern. The stepper motor can extend or retract the moving position of the ratio control valve. This is called pulse width modulation. The transmission control module knows the stepper motor is functioning by the changes in the speed of the two variators. So when it sees a ratio issue, it blames the stepper motor and sets a stepper motor code, which is typically P1778. But it is not grounds for replacement unless you have checked the hydraulics that control it. Next, we're going to look at the fluid path that fluid takes